Hey, good to be here. I hope you can hear me properly. It's actually amazing to see so many people at CodeCrafts. Yeah, probably Manuel already told the story. But when we started to think about this conference a few years ago, we actually just wanted to build something where we can bring the whole Viennese community together. And yeah, it just feels amazing to see this, what all these wonderful people are doing here to kind of make this reality. And yes, Manuel said, I'm also very sad that Greg is not able to join us today. We just got the info very lately, so that's why he asked me if I can take over his slot, and I'm happy to do so. I will probably talk a little bit about a different topic than he would have done, and I would talk about architecting for scale. So some of you probably or maybe already know me from conference talks like this, and I have a strong background in distributed systems, so I would say my whole entire career. I was mainly working to help organizations, get complex, complicated distributed systems right, and that's also the focus of this, what I'm talking here about, architecting for scale. And for those who do not know me, I'm David. I'm based in Vienna. I shifted my focus since a few months now mainly to our Munich branch from Square. So that's why I'm not around that often at community events here in Vienna anymore, but more often in Munich. And I do a lot of things like this, and I like to really share my ideas, my thoughts, my opinions, my observations, and that's what this talk is all about, right? So I'm really eager to also hear your feedback afterwards. If you tell me, hey, in our organization that looks a little bit different, or have you spotted this already, or what's your opinion on that? And architecting for scale is for me a very interesting topic, because obviously it's the crux of our industry, right? The crux of our industry is that the more people we put into software projects, the slower they seem to get in terms of the velocity, in terms of what we deliver. And you realize this very well if you talk to people who were startup engineers, so early joiners in a startup. And if you talk to them after they maybe increase the organization to, I don't know, 70, 80, 100, 200 people, then they usually come up with this kind of complaint that they say, when we were 8 people, it felt like we were faster than now with 150 people. And of course, that's a little bit over-accelerated, but obviously there's a point that we are really bad, or I would say immature in our industry to really scale engineering, to scale building great software products at a larger scale of organizational scale. And beside this, what you also often realize is that not only the velocity drops if you put more people into projects, which is, I guess, kind of common sense these days, but also the increase of issues, the increase of instability in the system usually takes a big momentum. The more and more people, the more and more bigger the organization gets that builds such a software product. And this basically takes us away from our main goal as software engineers, right? And the Norse, I love this phrase from the Norse, that's why I very often bring it, always mentions our goal as software engineers to safely and sustainably reduce the lead time to thank you, right? Not just kind of deliver something, but really deliver something that makes value. And I would like to discuss this today a little bit, how we can basically improve our processes, our mechanisms, our architecture to basically invert this problem a little bit. But first things first, so each software project or each great product starts with great people, one or two, which have a great idea and start to implement it, right? So we have a very simple system, easily to overseeable, not too complicated, not complex at all yet. And if you do a good job in doing that, obviously your system grows, right? And at some point in time, you need to pull in more people to kind of build a system. And out of a simple system, suddenly you get a complicated system, and the system grows and grows and grows, as we all know. By Lehman's law, right? Programs, complexity grows until you are basically unable to maintain it anymore. Then where it probably will stop, because you will not be able to add new features anymore. And what we then, of course, do, and we are really good in this as an industry, and I guess Ted in the final keynote will maybe talk a little bit more on this, but we're really good in finding abstractions, right? We are this industry which is just all built up on abstractions, right? So we started with zeros and ones, and basically we have now modern languages that allow us to basically completely abstract the hardware, right? And now we have LLMs that actually completely allow us to abstract our compilers and stuff like this. So we do these abstractions, and these abstractions are obviously massively useful. And you could also name these abstractions kind of subdomains, how we slice our complicated systems into smaller subdomains so that multiple teams can efficiently in parallel work on it, right? And I think that's so important to mention, and for those who maybe not work so much with architecture yet, I think for them the key takeaway, or basically for all of us, the key takeaway should be that good modularization is always the foundation for any well-designed software system, right? You can do whatever you want, you can try to scale your system. If you don't have a good foundational modularization, we'll talk about what's good modularization in that sense, you will not be able to kind of exceed with your engineering organization. And what I usually raise in this point is that I think we see a misunderstanding in our industry, right? When we start to modularize our system, when we say, okay, we have 3 teams now, let's figure out 3 subdomains so that these teams can independently work on some parts that are cohesive to each other, that we usually mix this up with distribution, right? So in many cases, we then say, okay, let's slice this up, right? Let's build 3 services out of this subdomain. And this could be true, of course. This could make sense. We will talk about when this will make sense in just a second. But it will not solve our problem of modularization, right? So distribution and modularization are 2 different axes on that scale. So you can have good and bad modularization, and you can have low and high distribution, right? If you have bad modularization in a monolithical environment, I would say, then you usually end up with something which you tend to call a big ball of mud. We're all aware of this, and Joseph Joda, who formed this term in a paper, usually says that sadly architecture has been undervalued for so long that many engineers regard the life as a big ball of mud as normal. And that's exactly the problem, and that's, I think, we as an industry regard big balls of mud as normal in a monolithical system that we then try to usually shift to more distribution. But if we do not get modularization right in a more distributed system, we do not gain too much value out of it, right? We end up with something which we tend to call the distributed monolith, and we will also talk about this in a second. So distribution is no reason for modularization, right? Or modularization is no reason to go for distribution. If you want to modularize your system good, you can still do this in a non-distributed system with a well-structured monolith, how we tend to call this these days, right? And I said I invested my whole career in distributed systems, and I love working with distributed systems. But still, you know, there's a multitude of reasons to go for distributed systems, but modularization is usually none of them. How Simon Brown, I think, states it much better to say if you can't build a well-structured monolith, what makes you think that you can build microservices that follow this nice modularization? So what's actually the reasons to then split up the single deployment unit? Why should we actually do it? If I just tell you, you can also modularize a monolithical system in a way that multiple teams can work on it. And I strongly believe this, right, to a certain scale. So first of all, I think there are multiple reasons, of course, to kind of split up a single deployment into multiple ones. The less spectacular ones are probably the ones which are technically driven, where we say, okay, we take out a part because we want to build it kind of in a way that it can independently scale, that we can 10x scale the smaller portion and the big portion stays on 1x scale. Or that we can say, okay, we have our whole system written in .NET or in Java, and we now need to build this kind of machine learning stuff, and we build it in Python, right? These are reasons to just kind of split up the deployment unit, or we want to kind of co-locate things. We want to say, hey, this part should work as closely as possible at the customer, so we split it up to have our whole system working in Central Europe, but these parts which are really closer to the customer should then directly run in North America or wherever they are needed, right? And that's, I would say, the simple thing, right? Figuring out where do we have those constraints, where do it make sense to split this up is actually the easy one. But that's, in most situations, or at least in my or our observations, the most or the less important driver for distribution. In most cases, we go for distribution because our organization, our engineering organization grows. So we have more and more teams working on that stuff. And as I said before, I strongly believe that with a couple of teams, 3, 4, 5 teams, you can still work in a modular monolith in a very efficient way if you just keep some principles on modularization or patterns on modularization in place. But at a certain point in time, you obviously get this well-known issue of one team breaking something, which in a single deployment unit obviously has the big disadvantage that it will probably break your whole single deployment unit, right? We also have patterns against this, right? If you think about resilience patterns, we can even ensure that this is not happening in a single deployment unit. But in reality, and this is usually the problem when we put more and more people into the single system. So the idea is to basically use distributed systems to exactly achieve this, to say when one team fails, the other teams are not affected by it. So classical mechanics of resilience in distributed systems, which we can ensure by breaking out from the single deployment unit. And the second most prominent reason you're probably all aware of is, of course, that we can not just deliver everything at once, but we can have independent deployments per team. And both of them are the main drivers, usually, if you go for distribution. And again, I can just repeat myself, both of them are just working if you did your homework before properly to come up with proper modularization. And that's so important also when I kind of join organizations in kind of decomposing their monolith, when we have exactly this situation, right? Where we say we have this big ball of mud and we want to get to this distributed self-sufficient services. And what we could, of course, try to do is now to say, okay, we go from there to there. And rarely that's working, right? Because in most situations, you will end up something like this, right? You targeted this kind of self-sufficient services, and you ended up in this kind of distributed monolith because you just didn't get the modularization right. And it's obviously, I would say, nearly impossible from my observation to get from a distributed monolith to a self-sufficient distributed system, because there seems to be this independent wall in between, which you cannot really overcome because it's so much more complex to refactor distributed systems than to do it on a monolithical system, right? So if you want to go from bottom left to top right, the more efficient way is probably to go back to well-structured monoliths, and from there kind of start the distribution. So, do your homework first, fix the modularization in your existing system, and from there on basically shift over to self-sufficient services. And that's, I think, one of the key learnings we made over the last couple of years. It doesn't bring too much value for organizations if you want to have autonomous teams, but telling them now build kind of distributed systems. You kind of need to get your boundaries right. You kind of need to get your modularization right. And I guess, for example, Nick, in the next talk, will talk about this a little bit more in detail. So, as I said, both only work on proper modularization, and both of them enable high team autonomy. That's what we're striving for, right? That's the idea of our industry since a decade now, that if you have more independent teams, we can parallelize the work and we can deliver software faster. And we enable them basically by introducing distribution. And that's the whole point of this talk here now, to talk about this concept of distribution and how this changes how we as architects need to design our systems. When you think about this slide I just showed you before, then, as I said, we have on the x-axis the amount of deployment units, the number of distribution. And traditionally, we were more on the left-hand side, right? When I started my career as software engineer, I was working in big Java enterprise monoliths, and it was always, kind of this, at least coarse-grained deployment units. And the issue we had there usually was reliability, right? So you said, okay, my system should sum up 2 plus 2, and it returns 5. Reliability issue. Obviously, the system is not working correctly because it produces wrong results for given inputs. And we as an industry learned a lot in this aspect, right? We do continuous testing, we do test-driven development. We have a lot of great tools and vehicles to come up with solutions for these reliability issues. And of course, these reliability issues don't go away if you start to distribute your system now. But there's a second very important point now which you need to take care of if you start to do distribution. That's, of course, availability. And in my workshops, I usually then ask the people there, so hey, can you explain me what's in your point the difference between a method call within a single deployment unit, so in that case module A calling module B to create a user, and basically doing the same thing across multiple deployment units. So we have service A calling service B via REST API or whatever to create a user. And I'll let them discuss usually, and then I just say, the answer is very simple, because it's basically everything, right? Everything changes if you do this. Because for a single deployment, it's rather straightforward. The thing is running, or it's not running, right? There's not too much complexity in there. Running, not running. If it's not running, you can anyway do nothing in the system, but if it's running, everything is up and running in terms of availability. If you split this now up across multiple services, then you, of course, open Pandora's box. In the best case, both systems are running, right? We all know that's rarely the case in complicated, complex distributed systems. And we also know that it's rarely the case that nothing is working, right? In most cases, some parts are not working. So, for example, service B is not working. Or service B is maybe partially working, right? It's a little bit, kind of hard to understand when it's working, when it's not working. Or maybe the network is just broken. Both services are actually green, but they cannot communicate with each other. And for example, the fallacies of distribution are here a kind of a nice metaphor to keep in mind. Those 9 rules why networks are inherently complex. And when Peter Deutsch introduced them in 1994, they did not really change that heavily, because the fundamental constraints of networks in our software solutions remain basically the same, right? So once we decide that we need to scale our engineering by shifting to more distribution to enable autonomous teams, we obviously or inevitably open the box of that we need to optimize for availability within the system. And what we often observe then is that people try to tackle this problem or try to tackle distributed systems the same way as they try to tackle, building monolithical system. And to just ignore this new aspect of availability. And that's, of course, problematic, right? And I just spotted this a couple of weeks ago again. I was with a bigger startup, and they have kind of, performance stability issues, I would say. And there was this loan team, so this idea was to build a system that can, easily decide if you get a loan or not, right? It's not mind-breaking on a meta level, but the idea is basically that you have some, kind of interesting new insights how to decide if people get loans for the houses or cars and stuff like this. And this team was constantly complaining. They say, our system is not working because we get basically wrong inputs from some downstream systems, right? Or the downstream systems are not available at all, right? And what they then usually need to do is they need to kind of, take the big glasses and run through the whole organization for 2 days to figure out what is actually broken again, which requirement has changed, why are things not compatible anymore. And at some point in time, they will maybe figure out, okay, the account team has a misconfigured service running. And this misconfigured service kind of resulted in the fact that we cannot do any loan calculations at all anymore, right? And then they could, of course, bother them and say, hey, please fix this stuff. Put this in the back of your backlog to finally get the screen again, that our loan system actually works. But if you did this, right, the next problem will occur. And you're just, running the whole time, the whole day to the organization to figure out what is now not working, why is my system actually not available because some sub or downstream systems are not available, like a database goes down and stuff like this. Or a network is broken, or some service is misconfigured. And that's a reality I often see, that people are still striving in such highly distributed system for a stable environment. But the reality, there is no stable environment in a complex distributed systems, right? There will never be, right? In classical monolithic systems, maybe we had the fact that, okay, this thing runs or doesn't run. In a complex distributed systems, there's for sure 1 or 2 services which are not working properly, which have, kind of the hiccups and stuff like this. So we need to architect for resilience if we want to architect for scale. And a good example, again, from a real-world use case is that I supported an organization a while ago, and they had this payment team. And this payment team was also, again, constantly complaining to say, hey, we cannot take new payments, and payments are obviously an important, I would say, customer journey in this organization, because our account service is not working in that sense that we cannot fetch the users. And of course, the first answer would be, but well, why is your whole system, why is your whole payment service going down if the account system is not properly working? Should we maybe not fix it in a way that we say, okay, we cannot do a payment because we cannot fetch the users? But again, would not be a very sufficient solution if you can not execute payments whenever something in the user subdomain goes down. So probably we could just increase the resilience by some simple architectural patterns by introducing a cache, right? So if now the account service goes down, we still have probably some of the users in the cache and at least can proceed by them. Or we introduce something like event-driven architectures to say, okay, whenever a user is changing, we publish an event and we kind of consume this event and put it in our read model and then basically ensure that we can execute payments because we have all the users which we need in the way as we need in our domain, right? And if anything else goes down, we can still execute payments. But also the other way around, right? This team then was often complaining to say, hey, the marketing team, it breaks our service because it's such a legacy old proprietary solution which at some point in time, once in a month, will completely DDoS our service to ask for the latest payments, right? To do some marketing analysis. And we all know this probably, right? But it's not really the fault of this legacy system. It's the fault of us as architecting this, right? We need to understand this and we need to come up with capabilities to basically ensure that upstream systems cannot bring us down by introducing, for example, again, load balancers, service circuit breakers, or just simple caches, right? And the overall idea is that we need to architect those systems in a way that they can independently work by decoupling them, by using all these resilience patterns which we are so familiar with in our industry. And I would even take this point a little bit further. I think it's not just that we need to understand that the time of stable environments is over in distributed systems, but we really need to embrace the chaos or accept it, right? And I usually then ask, hey, who of you has a disaster recovery plan if one of the most critical databases in the system goes down or is corrupt? Who has such a thing? Usually it lies around somewhere in Confluence, right? You created it 2 years ago. 50% of the people who were in this call were actually answering emails, but you have it somewhere in Confluence, right? And you believe that if it happens, this page will help you, right? The reality, it usually doesn't help you, right? It's the same with everything. You need to train it. And I think that's why we sometimes want to run our production not even running smooth, right? We want to have it chaotic because we want to basically ensure that if something goes wrong, we have the right processes and mechanics in place to build a self-healing and self-recovering system. And the best way to do this is to train this, to make game days, right? To do some kind of chaos engineering and say, hey, you know what, I shut down this database now. And just a few weeks ago, I met a former colleague who is now with Netflix at a conference, and I asked how he's doing, and he said, yeah, today is a very busy day because, they just shut it down, the whole data center in Europe again, to see if people can still stream their favorite movie without this data center, right? And I don't say that you need to be Netflix to do that, right? I just say that this is a very good example to see how they are doing this, right? To approach this problem, to already know that this at some point in time will happen, and it's better if we are well prepared for that. Because you basically, if you do this, you can be sure that this database will go down at some point in time. And I probably also promise you that it will happen at a Saturday at 2 o'clock in the morning, right? When one developer is on call rotation and then gets waked up crooky at 2 o'clock in the morning and needs to figure out how the database is currently broken, right? And that's what I don't want to have. I want to have this planned on a Tuesday at 10 o'clock when everybody is in the office. We say, hey, we shut down the database and we see if we can handle the system, right? And I also don't say that you need to do this in production. You can do this in staging, whatever fits your demands, right? I'm not telling you do all this great stuff. I'm just telling you these are ideas how you could involve your system in this direction. Because the point is obviously, right, that a service that can run in a stable environment will only run there, right? But a service that can run in a chaotic environment can run everywhere. And that's the whole idea of architecting for resilience, right? And what I find quite interesting now, if we have this base understanding that our systems are constantly changing, then we also know that basically based on that, our systems are not constantly changing, but our systems are constantly breaking, then this also gives us a huge insight into how our systems actually should be modularized, as I said before. Because if we say, okay, the service can go down, the service is maybe a little bit broken, and if we then consider the customer journeys through our system, and we, in that case, for example, e-commerce, say we want to buy a new product, and to buy a new product, we need to go to the user service, and then to fetch the user, and if we got the user, we need to go to the payment service to trigger a payment, and the payment service then needs to fetch the user again, and then the payment service basically needs to fetch an account and stuff like this. Then this is exactly what we want to avoid, right? Because we ended up in this entity service anti-pattern, and we ended up in this distributed monolith. And I think, again, we as an industry have I would say, a common understanding that this is not how we should slice distributed systems based on entity data, right? But we should slice it probably based on customer journeys. And say, okay, we have, for example, an order service where you go when you need to kind of order a product. So kind of a, services along customer journeys or self-sufficient services. So whenever you need to order a product, you just go to the single service, and this single service can do the stuff for you. So if all the other services are currently broken, you can still order your product, right? Sounds, of course, simpler than it is, but I think there's a lot of importance in this simplified example. And I usually figured out over the last couple of years that you can probably measure the quality of service-based architectures by the number of hops that are needed for the most important customer journey through your system, right? So if you, for example, are in this domain which we've just been, and if you say, hey, ordering a product is probably the most important journey through my system, and if this thing, now takes 15 hops, right, then you know that you probably did something wrong in modularization. I don't even want to say that you did something wrong in modularization. Maybe just your product has shifted, right? Maybe the slice was correct 5 or 10 years ago, but maybe the world moved on and your value proposition or what you are offering as a product is constantly shifting. And again, this is a question of modularization, right? And modularization, as I said before, is an age-old thing in our industry, and I really can refer to this old paper from Parnas on the criteria to decompose systems into modules. And what Parnas 15 years ago, right, I think it was 1972, so more than 50 years ago, already figured out in this paper is to compare, is it better to kind of split systems based on data models, or data objects, I think he calls them, so entities, or based on workflows, which I think he calls flows in general. And he figured out that basically it makes more sense to structure systems across flows. So basically just the same thing which we realized in the last couple of years in building microservices, that you should split your services based on customer journeys, which is of course quite interesting. But there's a point in Parnas' paper, right? The alternative is obviously entities. And there's obviously a mismatch between those things. So if you slice across customer journeys, then you will always end up with the situation that those customer journeys have, kind of an overlap in data. So in our case, all of them need users. And how do we solve this, right? By not just introducing another service which, kind of provides users to all of those customer journeys, which again becomes the resilience bottleneck. And the answer is, again, simplified, quite simple. But first of all, you need to decide who owns user, right? Which of these teams is actually responsible for the data entity of users? And then you can, again, for example, with event-driven architectures, ease that problem by saying, okay, whenever a user is changing, we publish an event, and whoever needs a user basically just consumes this event and builds up its own read model, hydrates its own projection to basically then have users when they need them, right? But event-driven architecture is, of course, not the only way to do this, right? There are other ways to synchronize data across systems that are useful in that sense. But if you, of course, want to have independent customer journeys, you also kind of need to distribute your data in a way that these journeys can really independently work with data. And ultimately, this again would really increase our resilience. So if the central service who owns users goes down, the other services are not affected because they basically build up the projection based on this data. So architecting for end-to-end responsibility is probably one of the most important things we need to do these days, right? To really understand what is the right modularization that teams can work independently, and that these teams can actually also independently own the services, and that these services then run resilient in terms of that they are not dependent on each other all the time. And if you did this, and we see more and more organizations being there, right? Having understood this, having said, hey, we basically have these resilient services. We have understood that distributed systems are chaotic, right? We need to ensure that these systems are not strongly coupled to each other so that they can work independently. We have teams that, own and subdomain end-to-end and can really deliver business value without, kind of pinpointing to other teams all the time. Then there's, of course, another problem, right? Which I just realized again last couple of weeks again. So if you're really in that area, if you're already optimized for autonomous teams, you often realize that those teams are building up their own kingdom, right? I'm not saying that's always happening, but there's a tendency that autonomous teams lead to organizational silos or local optimization, which I observe quite frequently these days. And I just bring you an example. So let's say we have these 4 teams, and all of these 4 teams now need a storage solution. So the one team says I need S3, the other team says I use Minio and I hosted my own, the third team says I use Azure Blob Storage, and the fourth thing says, okay, I build it again with S3, right? Then this is very locally optimized, because these teams are obviously very fast in doing that. It's not a big deal, right? It takes a couple of days to set up, everything that you can store your stuff securely on S3. And if you kind of combine this, kind of these local efforts, you of course come up with your global efforts in that sense. And from an inside view now, this sounds reasonable for a team, right? Because they say, hey, this doesn't take as long, I just do it on my own. But from a global perspective, of course, this is not useful anymore, because you could just say, okay, one team builds a proper storage service or proper storage module which other teams could reuse, right? And if you compare this then, of course, the efforts to do this on a global level once would be bigger for that single team, because that single team would invest more time to build something that is reusable for other teams. But on a global scale, of course, it would pay off, right? And I'm again not saying that this is always useful, because you're, of course, shifting what's on the critical path. If you say all the 4 teams can in parallel kind of do their work, need to do more work, but can parallelize it, or we say one team needs to do it, we cannot parallelize it, but it takes us long on the critical path. So again, I'm not telling you what to do here. I'm just telling you that this is a problem which we, of course, observe and which we need to take care of, or a potential problem. And the cool kid in town to solve this issue, and I talk a lot about this, that's why I also bring it here on the slides again, is platform engineering, right? To say we bring up a platform team that basically exactly does this, right? Accelerates our teams by giving them some fourth path or golden path where we say, hey, this is actually what you want to do, right? This is what you need, and you get 80% of what you usually need from this platform. And these platforms can be a variety of things, right? Can be real platforms, can be design systems, can be like a storage module here, whatever is needed. It's not that you kind of need to think of these, classical platforms where, you invest hours and years in building them. It's really something which all teams kind of would like to use and like to use. And we usually talk in the concept of platforms as a product. So we don't force the teams to use these platforms. We tell them, hey, we have something. If it makes sense for you, use it, right? If you still think it's faster to do it on your own, you don't have to use it, right? And this is how we can measure the value of our platform. If nobody wants to use it, probably it's not the right abstraction, probably it's not the right features, probably it's not the right thing which we offer in our platform. Another more simple way to avoid this, silos in autonomous teams would be to come up with RFCs. To say, hey, whenever somebody of these teams starts to build a bigger epic, right? We expect an RFC, which explains what are you doing there, why are you doing that. And other teams can take a look at this. And if they see, hey, these guys are building a storage module now, I also need a storage module in a few sprints, I could already poke them to push them in the right direction to build a storage module in a way that I can easily reuse it. So RFTs are obviously heavily, I would say, a big advantage if you want to avoid the siloization in autonomous teams. And last but not least, maybe if you have the problem that you have teams building their stuff in a very specific, team-specific way, right? They use their own frameworks, they use their own patterns, they use maybe even their own technologies and languages. So it's really hard to understand, okay, what is going on there, because it's completely done in a different way than what's going on there. Right? Programming languages are, of course, the classical example, but it could be much more. It could just be, hey, we follow complete different concepts, how we architect our services, or whatever it is. And I think a fantastic way to do this is, for example, to ensure dynamic reteaming from time to time. To say, hey, we take one person from this team and put it in another team, right? Every 2 months, we basically shift the teams a little bit around, not completely, but we basically ensure that everybody, kind of, at some point in time, will maybe join another team. And then he has, or she has, of course, interest to kind of harmonize those things and keep them similar so that you can easily work with those different teams. So architecting for system harmony is, I think, the third big point which I would bring into the game. After architecting for resilience, architecting for independent value streams, and kind of ensuring that your architecture supports harmony across the teams. And to come back to the crux of all this, right? Why architecture these days is such a challenging area, I would say, is because, and again, I think Nick will elaborate on this much deeper, is that usually architectures are these days socio-technical constructs, right? It's not the way that we build distributed systems, as I tried to show you, to just build distribution, right? It's the way to help organizations to scale, because only if organizations can scale, we can scale our software engineering process. And architecture needs to support this, right? That's why we go for distribution. That's why we go for verticalized systems. That's why we go for microservice. It's usually an organizational-driven part, not so much that you want to have independent scale there or there, right? It's that we want to have autonomous organizations. And organizations are obviously mainly driven by the domain, or we could say by the product, right? The product drives, in that sense, architecture. And as I said before, architecture is not bad per se. Maybe it was the right fit for how our product looked 5 or 10 years ago. Maybe our products are heavily shifting, especially if on a digital market, right, where software is really your product. We see that these product visions or these product propositions are constantly shifting. We kind of change our key value proposition, or we maybe kind of move into new markets, and we have this constant change all the time. And this product, of course, doesn't only affect our architecture, but this product changes also affects our organization. And this organization, again, affects our architecture, right? So organizations are constantly changing, right? They are shrinking, they are growing based on the market demands. Whatever is needed, it's not that this is set in stone, right? And that you can take a look at once, how is my product actually modelized and how does the organization best fit to this? I derive the architecture from it, right? Everything is constantly changing there. And this, of course, means that we constantly need to evolve our architecture. And how Nielford usually says it, everything constantly changes in unpredictable way. That's the main constant in software, right? And I think we can all agree on this. We realize this on a daily basis. So this is inevitable, right? It's there. We need to architect for change. We need to understand that there will be a change. And for example, we have this payment service now, right? We're happy with it. The team is doing a great stuff, great work. We have a kind of well-aligned team, and now somebody says, hey, the fraud detection logic in this service is so good, we want to kind of move this out because we want to make business out of it, right? So even if people do not use our payment services, they should at least be able to use our fraud services. So we basically say, okay, let's shift this out. Let's split up the team, right? Let's make 2 teams out of it. One with the core domain of payments, another one with the new core domain of frauds. And this is, of course, the easy part, to just take the logic, right, put a new API in front of it. The hard part is usually data. And Dave Thomas, in the afternoon, I think we'll talk about the pain of migrating data in legacy systems. But obviously, it's the thing there, right? To get this data from left to right. So to really, again, make this service independent, autonomous, right? It doesn't bring us value if we just build a proxy with their own API in front of it. If this proxy cannot do anything if the payment service is down. So shifting this data is usually the hard part, because you have a lot of readers and writers on this data, right? Maybe abstracted away via APIs, or maybe going directly against databases, especially in legacy systems. So you need to shift those readers and writers first, that you can ultimately also shift the user fraud data. And the first problem is that this usually only works with downsides if you do it with downtimes if you do it in a big bang manner, right? So if you say, okay, I go into a downtime on Friday afternoon, I shut down my 2 systems, I take a copy of the fraud data in his own database, transfer it to the new database, and when everything is done, I kind of spin up the new system so I don't have any conflicting writes in the meantime. So even if the downtime could be small, in the best case, we have it, right? And then you realize, okay, shit, this API is not working that good as expected. We have some critical issues, so we need to roll back, right? And we've all been there. I know it, right? And we hate it. We even hate the memory of it. Sitting there saying, oh no, this is not working as expected. Let's, shut this new system down again. Let's spin up the old system again. Let's take all this data and shuffle it back again, and let's change the readers and writers to the old system. And then we need to fix it. And at some point in time, we will probably do the same thing again. We meet again on a Friday afternoon, shut down the system, migrate the data over, and do stuff like this. And this is literally the stuff that gives me a heart attack, right? I cannot work in such an environment anymore. I don't know, I'm getting too old probably, but it just doesn't feel good, right? It feels really, really bad if you're in this situation, if you're sitting there on a Friday afternoon, and if you need to go through all this journey back and forth all the time, and then you realize, okay, this data was updated in the meantime, we have a conflict there, yada, yada, yada. Just painful. So we need to architect, obviously, for better ways to do this. And again, event-driven architectures come here very handy to say, okay, whenever we, for example, have a change in user fraud data, we publish a new event. For example, if we have a legacy system, we can also do this with change data capture, and then we put it in a database of the new service. And by doing so, we could potentially already migrate the readers. We could already say, okay, we migrate the reader because basically all the data is copied over. Of course, there's some eventual consistency which we need to analyze and take care of. But usually, a system is not just readers. In most cases, systems write and read. And there we have usually then the problem if they don't write and read from the same node. It could lead to consistency constraints. So we probably also want to migrate the writers. So we could kind of close this loop and say, okay, whenever somebody writes into the new system, we again publish an event and kind of, update the old database to that, right? And in that sense, we could simply, all simplified here, but we could allow to do this migration step by step. And if the writer now goes down, right, we can say, okay, let's shift it over to the old system. It's Friday afternoon, let's fix it on Monday. Let's work on a proper fix, let's push it to production again, and let's see if it's working. And this is how we can step by step then migrate those things over and ultimately can remove the user fraud data from the existing payment service. Right? And this is how you want to have this working. And by using this, you can then simply say, okay, and we can build new systems on top of that, right? And we have these zero downtime migration scenarios in mind. And other ways, not just in migration, but for example, in building new systems could be canary releases or dark launching or, the science patterns. All these things that basically remove anxiety from our developers to make change. Right? And that's an architectural topic. How do you architect things, especially in the transition, to kind of make the developers having to go with you, saying, hey, I get this. This will not give me a lot of sleepless nights. I want to do this because I see the value in the target picture, and I basically also see the way how we get there without a lot of pain. So let's sum up. What I wanted to point out for all of us, I think, independently of which seniority we have, that modularization is key. And I say this because I have the feeling that we strongly over-engineer our architectures and strongly under-engineer our system design in that sense, right? We strongly go for, heavily distributed systems without, understanding what are the right modularizations, which we can also achieve without distribution. And modularization, if it's done right, and only if it's done right, because if it's not done right, it gives you the opposite effect, but if it's done right, you can build distribution on top of it that enables autonomous teams. And that's why we usually do distribution, to enable autonomous teams. And distribution, as said before, gives this additional constraint of availability, which we need to architect for. So it's not just reliability in such a system anymore, which we need to optimize for. Of course, it still stays reliability, but there's this new kid in town which we need to optimize and architect for, and this is availability. And the complex distributed system will never run in a stable environment. Keep this in mind. So I tried to come up with these 4 points. Of course, there would be a ton more to talk about or address, but I think they are essential to understand. First, architect for resilience, right? As I said before, ensure that the system is working still if parts are not working, and that's I would say, a central architectural work which we need to do there. We architect for end-to-end responsibilities, so we kind of need to get our modularization right, and we need to ensure that the systems then can really run independently. We architect for system harmony, to not come up with silos in these autonomous organizations, and we need to architect against change anxiety. And by doing this, I hope we can make Dan North happy to keep the lead time to thank you low even at high scale. Thanks a lot. I hope this was useful.
Thank you. Thank you very much for your talk, David. Not too much fire on the slides today. Some questions from the audience somewhere.
Hey, David. I kind of like the concept of reteaming, as you said, like take one person, put it into another team for 2 months. But like we were just shortly discussing, how does it doesn't end it up like you just have an intern every 2 months that you have to school in?
Yeah. No, I think, complex questions, so I try to give a simple answer, but we can maybe discuss it at a coffee later also. But I think what's important, that retaming doesn't mean that we go with feature teams again, right? It doesn't mean that we kind of go into this role again where everybody kind of, can do whatever he wants. Every team kind of gets assigned some random task, right? It's really that we keep these domain teams, right? We keep them, and we just take out people from time to time to, for example, enable that, we kind of have harmony in our architecture. But harmony in the architecture is not the only thing, right? It also gives diversity in the teams, right? It gives new perspective into the team. So, this is just a side effect of doing that. So there's a great book on dynamic reteaming, which covers this topic much greater than I did. I just see this as a side effect if you do this, that you can ensure harmony within your teams. Did this answer your question? Partially, okay. And in the end, it's a trade-off, I guess, right? If you do it too intensively, if you change it every 2 weeks, right, again, then it's probably overdone. And there's no general answer on this, right? You really need to understand your organization. How often do you want to do this? How big is the trade-off between, changing working teams, but ensuring that you still have harmony in your architecture? But would be interested in your insights if you have some in this area.
Thank you. Are there, over there. If you may throw the cube just over there.
Wow. I think this gets a round of applause, right?
Does this work? You're just talking to the... Oh, yeah. Could you elaborate on how... or what do you mean by slicing based on customer process, I think?
Customer
journey instead of entity. Because to me it seems it's inevitable to slice based on entity. I mean, just by storage or something, multiple services will probably require something. So I don't see how you can not slice based on that.
Yes, I would need some backup slides here for that, but I can try to visualize it with my hands. So the thing is, as you said, right, customer journeys are usually in conflict with entity data, right? There's this customer journey entity data mismatch problem that you say, okay, I have my product ordering process, I have my payment process, I have my warehouse management vertical, and they kind of do their stuff. And all of them at some point in time will need users, right? And I did this on a couple of older presentations. I hope I visualized this quite nice, but what we often did then in distributed systems, right, that we built these entity services in the background, right? We had entity service and we have customer journey service, which led to, kind of massive bad resilience, because in the end, if the entity service went down, all the customer journeys also did not work. And that's, I think, where reactive architectures, for example, help us a lot by saying, one of these verticals should own users, right? And whenever this user changes, we publish an event, right? And whoever is also interested in the user, maybe all other verticals, they consume those events. And they rate with these events their projection, their read model, right? So in that sense, you kind of duplicate data, but not really, because it's, you know who is the primary owner of the data. And by doing that, you, of course, increase the resilience of your system, because you are at runtime not depending on this user service anymore. You at runtime, when you get the request, have all the data in your service boundary which you need, right? Does this help?
Yes. I guess it sounds nice, but in my experience,
Yeah.
I don't know if that's feasible, because some of these entity services are so big that no one team that is already handling some product could also take care of that.
Okay, yeah, that's a good point. So if you say, I don't know, user management is such a big domain, maybe you have a legacy system, a CRM system, whatever, right? Then I think you just need to think about these 4 patterns of team topologies, right? So I talk mainly about stream-aligned teams if you translate it, right? If you would translate it, you say, hey, you have these 4 stream-aligned teams. And I also quickly talked about platform teams. But you could consider in such a system as a complicated subsystem. Right? Say, hey, user thingy is actually not bringing direct value to our customers, but it's obviously so complex that it would kind of overload the cognitive complexity within a team, that we shift it out, right? That we shift it out as a dependency as a service, and we have one team which takes care of this. And the only goal of this one team is to provide us these users in a way that we as a stream-aligned or verticalized teams are fast in delivering stuff, right? So I think if you really have such a subdomain which is so complex, right, and you cannot just move it in a verticalized teams, then I would probably go with a complicated subsystem team. Right?
Okay, thank you.
Okay?
Okay, thank you. I guess we have space for one more. So,
hello. You on the last slide, I think you show how you can extract fraud service from the payment service, right? And the writers go to
Yes.
both of them. Is it like that we can have a problem that, for example, you need to keep logic in 2 places for the longer time? For example, if you need to develop new features on the fraud domain in the both places, then the longer it goes, the worse it gets,
Yes.
basically.
Yes.
Right?
Yes, exactly.
So this should be like a really tight time constraint, how you move out those fraud domain from the old payment service, because if you don't, you will end up in keeping same logic in 2 places.
Yes, yes,
Yeah.
exactly.
Yeah. So
Can only fully agree. So you need to measure this stuff, right? You need to come up with a clear plan. You need to come up with a roadmap, as you do for every kind of important change you do, to say, okay, the idea is that by end of the year, 80% of the database consumers are going to the new service already, right? We do this by doing that and that and that and that step, right? And we try to kind of figure out if we are going into the right direction. And we generally do this because we want to have, the fraud domain independently of the payment domain. And then I think people usually understand this. And if you, as you said, you should not kind of, spread this forever, this transition. But it's still, from my perspective, again, in most cases better to have a transition, right? Where you have exactly these problems that you maybe need to fix bugs or do changes in business requirements on both sides, than to do it not and have a big bang, right? Of course, that's the alternative. Depends a little bit of the complexity of the change. If you say, okay, there cannot happen anything by transitioning from one to the other, and we can do it in a big bang, then probably somebody lied to you in the first place, because there will happen something. But of course, then you can say, okay, we do it just in a one-shot thing. But usually in more complicated systems, that's something which is hard to achieve and which is usually painful. But I agree with you that we should keep the transition phase to a bare minimum, but as long as needed.
Yeah, you need to be really narrowed down to the time, because if you spread it longer, it will be really a lot of burden.
Exactly. You need to do good stakeholder management, right? You need to explain from the beginning on the sponsors, the business, whoever kind of, drives this transition very clearly what you achieve when and what's the value. Because often we see in these technical transitions that at some point in time management loses traction, right? They say, okay, you did some stuff, I never fully understood why you do this and why you're doing it, right? But now, money is over and you have 50% of the stuff done, and then you actually end up in this situation, right? So I think, talking to people, convincing managers, sponsors, whoever kind of drives this is crucial there, to tell them, hey, we have a plan. That's what we try to achieve. We give you every 2 weeks an insight on the plan. And if something goes wrong, we will also inform you, right? That we maybe need to prolong this phase or stuff like that.
Thank you.
Okay. Then I say, once again, thank you very much, David,
Thanks
for
a
your
lot.
talk.